and female, the variable film genre with the categories drama, action, comedy, etc. Now we're having two variables. So we might have gender, male and female, and film preference with those drama, action, comedy, and so forth. That's what we're doing now. The process is the same. It's just more complicated because we're figuring out the percents expected based on rows and columns. So it's a little bit more complicated. And so let's just go through it first on the slides, I guess. So the chi-square for goodness of fit that we just did, we have one nominal variable with two or more categories. Gender with two categories, car color with these four categories, college major with these categories. But now we're doing independence, two or more nominal variables. So we might have two variables, gender, male versus female, and car color. So we might be asking a question like, does preferred car color differ based on the gender of the individual buying the car, right? That's what we'd be asking. Or three variables, gender, male versus female, and car color and major. And so we'd be looking to see if these things impact people's preferences or whatever we're asking. So the example that we have, we're going to go back to the real study, the cereal box study. Let me try one more time to see if my application files are opening. And we already did this study, but they have added another variable to it for us. And hang on here. I think my Excel might have wonked out. And if it did, then I'm going to end class and record this lecture. It shall be a little, and record the demo, which will be a little harder here. Let's see if I can just get those up. I'll give you evidence that where things are a little goofy here right now. Here's my folder. Here is my classes. Here's this class. Here's where I usually keep the applications. Let's just see if this one's, okay, that one's coming up now. So let me go down to chapter 13. Okay. Okay, it's still coming up here. All right. That feels better. Okay, I was just a little worried that I had somehow had something go out of control there. All right, so back to the cereal boxes. They were interested in an additional question. They weren't just interested in whether there were more males and female characters. They were also wondering in how those male and female characters were portrayed. And so we already know about the gender, and we had done this example. All right. But now they wanted to have another question. We already know that males outweigh females on cereal boxes. It would be even worse if all the female characters were children, like little girls, right? And all the male characters were like macho men. Like that would be even worse. So they're looking at gender disparity on these cereal boxes. And so the question they asked are male, females proportionally represented as to whether they're children or adult characters. And so we're going to have now two nominal characters, gender and age. And there were a total of 222 cereal boxes that had enough information to be coded for both variables. All right. And so this is what the data are going to look like when you're doing this kind of a problem. All right. We're going to use this test when we have two or more variables. And we're asking, is there a relationship? Oh, that word relationship. You won't be confused because these are nominal variables. Is there a relationship between the gender frequencies and the age frequencies of the characters, or are they independent? The age isn't based on whether the characters are male or female. And so the data looks like this. Of those 222 boxes, note where the 222 is. It's in the corner here. And then how many had male characters who were children? 28 of them. How many had female characters who were children? 30. Total of 58 boxes had characters that were children. Of the adult characters, how many were male? 125. How many were female? 39. We had 164 that were adult characters. So we have these total columns. So we have, these are called your rows, your row totals. And then we also have column totals. Of all of those 222 cereal boxes, 69 had female characters and 153 had male characters. All right. So that's what the data looks like. And this is called, note this phrase, this is called a contingency table. Contingencies are like ifs, like this condition depends on this condition. So the male condition depends on the age of the character condition. All right. And then here is just describing those data that I just talked about it. And so when we work with this, we can calculate the percent who are children, right? We can take this 58 who are children and divide it by the 222. We know that 26.1% are actually children. And the percent who are adults, 74%. Same formula we looked at before. We're taking the number of children and we're dividing it by the total to get a percent. All right, 26%. And we can do the same here. And so these are the kinds of calculations that we'll be doing in this problem. All right. And so next we determine what we would expect. We know that 26% of all the characters are children. We know that 74% are adults. If the proportion of female, this is a lot of words, I'm going to read them all. If the proportion of female characters who are children is no different from the percent of all the characters who are children, then we would expect, this is weird logic, then we would expect 26% of the female characters to be children, right? So of the female characters, we would expect 26% to be children. And of the 74% to be adult. And we would expect the same here. We'd expect 26% to be children and 74% to be adult. So that's the comparison we're making. I know this sounds really kind of boring now. We can figure this out by multiplying that percent times the number of females. We'd expect 18 to be children of the female characters. All right, and so that's how we're calculating our expected characters. So this is just kind of a nutshell of what we're doing. We'll look at it in the spreadsheet now that I found it. So what we do if you were doing this in a different math class is you would write it up like this. I'll show you. I'm going to erase my pen in there. This is what it would look like. When we calculated these percents, you would find out, first off, we knew that 26.1% were children, 74% were adult. When we compared that by taking 26% of all of these females, we found 18 of them should have been children. 51% of the females should have been adult. If there was no difference, if it didn't make a difference. And we know that almost 40 of the male characters should have been children and 113 should have been adults. So these are our O's and E's. The O's are here, the E's are here. And we're using the same formula to calculate O minus E squared divided by E. That's how we're figuring out these cells. But we have a lot of cells to work with, so it's a little more complicated. This is what it would look like if you were doing it like by hand, like, or in the old days, how they would have characterized this. Now we use spreadsheets, okay? We figure out the chi-square statistic in the same way. This is what it would look like if you were doing it sort of in the old days. You'd be taking this O minus E, this is for male children. We have the 28 minus the 39.9. Do you see where we're getting these numbers? We'd be squaring them and dividing by the E. And we'd be doing it the same for all of them. So if you were writing out the problem by hand, that's what you'd be doing. Remember, this is still the formula, but we have to apply it to all of these cells. So this is the cell for female children. This is the cell for male adult. And this is the cell for female adult. So that's what that formula would look like if you were going to write it all out by hand. Okay. And we'd come up with this, add it all together, and we'd come up with this sum, this 15.62. So if you were going to do all this by hand, you might do it that way. Okay. We'd figure out the statistical difference by looking at degrees of freedom. Notice the formula. The number of columns minus 1 times the number of rows minus 1. We don't count the total rows and columns. We're just counting the categories. So we'd have 2 because we had male and female. 2 minus 1 is 1. We'd have 2 minus 1 because we had adult children and adults, just 2 categories. And so we'd still have DF equals 1. Our cutoff would still be this 3.84, the one that we looked up before. Wait. Oh, yes, and our chi-square statistic is 15.62. It's way out here somewhere, so we would have to say it's significantly different, right? Our cutoff point is 3.84. The shaded region is all of this in the tail. Our chi-square statistic that we calculated. Highlighter. All of this is our significant reject region. We would be rejecting the null. And this is that table that's in your book that you can also use if you want to use this. You can see our 3.84 right here. That's where we got that. We had 1 degree of freedom with 0.05 significance level. And then we would decide, we'd have to decide whether to reject. In this case, we'd be rejecting the null. And we'd be concluding something like this. The proportion of cereal box characters that are children and adults is different for male and female characters. And that's our conclusion. So that's it. Okay. That's it. But let's do it in a spreadsheet. Let me just see what's on here. The contingency table we already looked at. What is it? You're going to see this phrase written. It's the distribution of 2 nominal variables, so the frequencies and totals are shown. Let me just see here. All right, and I think we're ready to go into our demo. We're going to go ahead and do the demo now. That is right here. I've set up the spreadsheet for you, but if you're working by hand, and that's an option for you, if that's helpful to you, you'll probably have it look like the one that I just showed you. And so we're going to do this next problem. We're going to do a problem in which the researcher is interested in whether there's association between travel preference and gender. Do male and female prefer differently? Does a preference for train, car, or plane differ depending on whether you're male or female? That's kind of what we're looking for, okay? And we're going to, the way it's set up here, since we're not doing it the same way, setting it up the same way as we do in the hand calculations, is we're going to have all our observed values here. You can see this is our observed table, our expected values here, and then our chi-square calculations here. So let's go ahead and write this problem out, and let's call it people people whose travel preferences differ by gender. And people whose travel preferences do not differ by gender. All right, our row variable, this we have to specify now. Our row variable is gender, male versus female. And our column variable is travel preference. train versus car versus plane. Our hypotheses, I think I'm going to add that row again so I can write it out. I'm clicking way over in to collect the entire row comparison distribution, right-clicking and hitting insert. And I did it in the wrong place, so I'm going to Control Z to get that out. No, that was what I needed to do, so I'm going to do, let's do a redo and a redo. All right, so let's make our research hypothesis. Population 1 has population 1, those who travel by differences vary by gender. Population 1 has travel preferences that differ by gender. I'm running into a logical fallacy here, so I'm going to change something in a minute. And population 1 has travel preferences that do not differ by gender. And I want to, I'm going to change this and just say people like those in our sample, because I'm running into a logical problem there. And I think I'll leave population 2 just as it is. Our comparison distribution is our chi-square distribution with DF equals what? I'll rewrite the formula. It is the number of columns. Whoops, number of columns minus 1. DF equals the number of columns minus 1 times the number of rows minus 1. The number of columns is 3 minus 1 times 2 minus 1 equals 2 times 1 equals 2. So DF equals 2. We can look up our cutoff point. I wonder if we should just use that chart this time, because it can be kind of interesting to use that. We'll just use the chart. DF equals 2. We'll test at 0.05. We can just go to this 0.5991. And I'm using this because I want to refer to these other numbers at the end of our problem. So we have a cutoff point of 0.5991. I don't think I need to draw that distribution anymore, because it was it 5.991? I think that's what it was. Let me double check. Where was that again? 5.991. Okay, so let's go back into our spreadsheet. And that's not DF, that's our chi-square alpha is 5.991. Our sample statistic, we now have to go ahead and calculate. The very first thing to do is to get our row totals and column totals. All right, so let's go ahead and sum up our columns first of all. I have these in light gray just because we're not using them for that. I don't know why it's in light gray. Actually, it's a little difficult to see, but we'll just leave it alone for now. And we should be able to just copy and paste that in. So it looks like in our sample, we had 53 people who preferred to travel by train, 160 by car, and 134 by plane. What do you guys prefer? I love train travel, but it's way too much money. It's unfortunate. Just darkening that so we can see it better. Anyhow, our row totals. Let's get these. And let's go ahead and get the total in 2 ways just to verify that we did everything correctly. We just sum up these row totals. Or we could sum up all the cells, either way. We got 347. I'm just going to do one more check and make sure we still get 347 if I sum up the column totals. So I'm going to just sum those up as well. And I get 347 again, so that's correct. Next thing we calculate our percent. You'll remember the percent column is just the row total times the overall total. Let's just put total for the row times the total. It's called the omnibus total. I'm not going to say that word. I'm just going to write, how could I write it differently? I'll write overall total. So let's get our percents. Here's our row total, and let's get our equals. Take our row total and divide by the overall total. That's 50%. It's rounded. If it were stated as a decimal, we'd say that it's slightly different from that. And let's take our %. This should add up to 100%. We can check it. We can see that it does, but let's go ahead and sum it.
Professor, for the row total times the overall total, is that what you're doing right now?
Yes. No, first it was, what did I say here? No. So this should have been divided by.
Oh, okay.
Sorry about that. Next, we're going to do the times when we calculate over in this table, and I just wrote it wrong and did it correctly. So yeah, we're going to take the 174 and divide by 347. And we should get then these percents that should add up to 100%. And if we want them to show up better, we can just format the cells so that we can see the decimal places, add a decimal place, and we'll see that there's, you know, a slight difference there. And so it does add up to 100%. Okay, it's these percents right here that we're going to use to fill in these cells. Sometimes I wonder if this is the best way to approach it. I always have to decide the best way to teach it, and this is the way I decided. Sometimes I wonder if you think there would be a better way to do this in Excel, you can tell me. But all we're doing here now in our E column, so our expected, I'll write the whole things out, our expected cells are going to equal our row percents. And here's where our times comes in by our column totals. And I'm going to put in our observed row percent times our observed column totals. And so what that means is we're going to take and put our equal sign. We're going to figure out what number of people would we expect to prefer train if gender doesn't matter. So let's take, we need 50.14%, and we're going to multiply that times this train total, 53. And we find out that we would expect 26 males to prefer trains. What would we expect for females? We would expect, so now we're going to take this female percent, this 49.86, and we would, of those 53, and we would expect, let's see if we did this right, 26.47 people times 42 people. What would we expect for car? Well, we'd expect 50% of these 160, about 80 is what we'd expect here. So equals 0.50 times 160. We'd expect 80 people. We have 85. We'd expect 80. And let's do this also for the females, 49% times 160. We'd expect 79 of these people to prefer, 79 of the females to prefer car travel. And what percents would we have for plane? We would expect 50% of our individuals, of our 134 people, to prefer plane. And 67 is what we would expect. And we would expect 49.86% of these 134 to prefer plane. And that would be 67 people. So this is what we would expect. So now we're asking, are these differences significantly greater than normal? And this is where we're going to finish the formula. We're going to write O minus E squared divided by E, a little bit longer formula. So equals parenthesis. So let's first do the purple cell for train. That's where we're in. Let's subtract the male. Let's square it. And divide by E. So this is the formula that I have for mine. I put parentheses and took O minus E squared, and then I divided by E. And I got this 0.48. Maybe that's something you got too?
Can you click on the equation again, or?
Yeah. So it's hard to see the cells that are highlighted, but here's the first one in the parentheses, the O for train. Here's the E for train. Then I squared that and divided again by this E for train. The purple E. That's why I color-coded the cells. Sometimes I wonder if I'd be better off just doing it the way we looked at it on the slide, you know, just doing it all in one. All right, I'm going to calculate these by hand, and then I'm just going to ask you if you think we can use copy paste. So I'm going to click now. I'm in yellow. I'm in the O for females. So there is the O minus the E. And I square that. And then just divide by that E again, that yellow train under the expected column. This could be bigger. This is our expected column. Did you guys get the same numbers? No? I think sometimes it's easier if you focus on the colors in the cells. At least that's why I put them there, because otherwise you can have your eyes be mistrained. Let's do one more by hand and then see if we can copy paste. So now I'm in the cell that is orange. I'm going to apply the formula just above it. I'm going to first apply it for males who prefer cars. So let's go ahead and get the observed, which is 85 of those males preferred cars. We're going to subtract what we would have expected if there's no difference by gender. Add your parentheses in here. I forgot my first parenthesis here, so I'm going to add that up in the formula bar. If I can get to it, there we go. Go ahead and square it using that caret and the 2. And then just click back in the car cell. Click back in that E cell. Let's do another one. I'm going to do now the females who prefer car. I'm going to start by clicking in the O. And don't forget your parenthesis like I just did, because we're going to take the O minus E and square it. And then we're dividing by the E. So there's the formula. O minus E squared divided by E. D11 minus K11 squared divided by K11. And we can actually copy paste here if we want to, because we don't have any referential, like we don't have to add any dollar signs. There's no static cells. So I'm just going to copy it. I'll preserve the coloring by just using this paste function for the formula. What do we have to do to get our chi-square statistic now? All we have to do is sum all those cells up, equals the sum of all 6 of these cells. We get a 1.58. So our sample chi-square statistic, chi-square sample, equals 1.58. Okay. Our decision, all we're doing now is we're comparing the sample score with the alpha, and we can see that we need a sample. If we want to reject the null, we have to have a sample score that's higher than the cutoff point, the chi-square alpha. So what's our decision?
Fail.
We're failing to reject the null. And we can just write up our concluding statement. We can just take, I'm just gonna write it out in words, actually. Conclusion. People's travel preferences do not differ significantly by gender. And we can put our statistic, chi-square, with our degrees of freedom in parentheses, equals 1.58, and we just need an NS there. And we're going to go ahead and do one more. Let me see here. Let me see if there's, I guess I just have those two, so I guess we have to do this one. All right, I think this is the only other demo I have for our sample. So, by the way, you can't do a chi-square if any of your cell sizes are lower than 5. So it won't work. It's statistically invalid. So you have to have at least 5 in every cell in order to run this test. We have 5. So we're okay, but barely. Okay, here's the problem. Any questions on the last problem? Any questions on this one?
My only question is for the homework for chapter 13, is there gonna be a problem like this?
Yep.
Okay.
Yeah. You have both kinds of problems. This is the one that's used more common if you were going to read a paper about this, so it's important to use it. I'm going to make these observed and expected a little bit bigger. Let's go ahead. I'm just doing it by right-clicking and just increasing the size just so that's a little more clear for us. So this is what we observed when we did the survey. And you can see here what's going on. Let's go ahead and figure out our populations. Let's just put, I think these are students like those in our sample. And let's compare it to students whose housing preference does not differ by degree level. This is like the degree that they're seeking. So our row variable, the variable is housing preference. We have 3 conditions. We'll put a colon there and we'll write dorm versus family versus off-campus. And then our column variable is degree level. And we have AA versus BA versus undeclared. They don't know quite how far they're planning to go. let's just abbreviate our hypotheses this time. We're just going to write chi-square for our research hypothesis, or HA it's sometimes called. We'll write chi-square is greater than 0. So that 1.58, that's like a chi-square of around 0. It's not significantly greater than 0. And our null, let's just write chi-square equals 0. Our concluding statement is going to be worded something like this, depending on whether it's significant or not. It'll be worded something like the way we wrote population 2. I'd like everyone to figure out degrees of freedom and put it in the chat. You should have the formula written down from your notes, so put it in the chat. I'm going to watch the chat now. I haven't been watching it this class so far. Good to know. Figuring out degrees of freedom. Number of columns -1 times number of rows -1 should be a simple calculation. Just do your calculation one more time, Shelley. Anitra looks good. Number of columns -1 times number of rows -1. Let me get one more. Jolana, good. Let me see one more in the chat, and then I'll call on someone in here. One more person, degrees of freedom. Easy math, guys. Shandina, what do we have? Yeah, we have 4 because we have 3 rows -1 is 2, 3 columns -1 is 2, 2 times 2 is 4. DF equals 4. Let's look up the cutoff point. Let's go ahead into that chart for a reason. Well, you guys can't see it, but let's just look on the chart. I can share this with you. It's also in your book. So when we have 4 degrees of freedom, we're still using 0.05. You can see that our cutoff point goes up, as degrees of freedom go up. So for 4 degrees of freedom, we have to get a sample score higher than 9.488. So that's our cutoff point. And again, I'm using that chart for a reason, because I want to show you something on it in the end. I actually don't remember how this test comes out, so let's go ahead and do it. So this, you guys know what to do, right? Let's start by getting all these totals and checking them. So go ahead. I don't even need to talk you through it. Get the row totals. And then I'm going to ask you to calculate percents. When you get your percents, put one of them into the chat. Put your percent for dorm into the chat so I know you have the right idea. I'll remind you of the formula. Observed percent, I'll write it correctly this time, is row total divided by overall total. I'm looking to see your dorm total in the chat. Thank you, Anitra. It sort of doesn't look right to me, though. Is it right? Yeah, yeah. Is that right? Anitra, I don't know. Recalculate there. It's not looking right to me. That looks right, Shelley. To know that looks right. Or I think maybe you were filling in the number already. I think you were jumping a step ahead, even Anitra, and you went beyond the percent and maybe filled in the expecteds. I'm not sure. What is the dorm row total, Tia?
243.
Nope, we should have a percent. It should be a decimal.
Oh, okay.
What you got was the overall total?
Yeah.
Yeah, so you actually need to get the percent now. So you're filling in right here. And I'm asking you, what is the percent that should be for dorm?
I haven't got that one yet.
Okay, do you? Okay, that looks right. Let's go ahead and get these percent. Let's take the row total and divide by the overall total. We get 31% there. And let's just continue that formula down. We should get 100% if we did it correctly. Oh, why am I getting, oh, because I didn't put my dollar sign in. Let me stabilize it and do that over. You could also just do these individually. It's not that many. There we go. And that looks right? It looks like, around a third is going to be each. We can always check it by making sure we add up to 100%. And we do, so we're good. All right, next we have to fill in all of these cells. And remember, what we're asking, the question we're asking is, what number of students would we expect to live in the dorms if these percentages are in place? These are what we would expect. And so in order to fill in the expected numbers, we're going to take the row percent, the observed row percent, times the column total for each cell. The column total for the observed, I guess. So in other words, we're asking ourselves, and for the number of people at the AA level who prefer or who are living in the dorms equals what is 31% of, we'll put the time sign for of these 95. We should have a number that's around 30-ish, and we have 29.32. So that's what we would expect. For the AA level living in family housing, what is 37% of this 95? There we go. For the off-campus housing, what is 32% of, there's our time sign, these 95? And we see we would expect these numbers, they look pretty good to me. I'm going to go ahead now and use a copy paste to do the rest of these. So for this, we're always going to be using this denominator of 120. We're looking at the BA level. What number of students would we think would be in each of these cells if these percentages hold true? So let's go ahead and get the 31%, and this time we're doing of the 120, and we can stabilize the 120 with our dollar sign. And now we should be able to copy that formula down. If you want to preserve your coloring, which I actually recommend just for your eyeballing, you can go ahead and just paste the formula in. And so these should add up to 100. We can check them in the same way. Equals the sum. Let's put a check together. I mean, these should add up to the 95 and the 120. So there's our 95. I'm going to put these sums in all the way through. Here's our 120. That's looking good. Let's figure out the right numbers for here. We can stabilize it and copy paste. What's 31% of these 28? Let's stabilize it. We know that about 8 students should be undeclared majors, should be living in the dorms. We have 5. Let's put our dollar sign there to stabilize it. And then we can copy and paste this formula. And when we're done copy pasting, we should get the 28, and we do. So now our expected values are right. Now we can just go ahead and do this big formula, and we should be able to copy and paste the whole thing in because there are no static cells. So we're going to just look above, copy it in. We can use the colors for reference, O minus E squared divided by E. You can see the formula up here. C10, which is the O, minus J10, which is the E, then we square and we divide again by E, and we get the 8.34. And let's just copy and paste this as a formula through all of these. I have it copied. I'm going to just right click and paste the formula. Good. Figure out the chi-square statistic. When you get it, tell me what it is in the chat. Put the chi-square statistic in the chat. The chi-square statistic is just the sum of all of these colored cells in the chi-square box, which of course you already knew you can use copy paste to figure that.
Going back one step,
Yes,
I kind of got confused for the chi-square at the third box under dorm AA level.
okay.
How did you do the formula in Excel? So that would be equal OE.
Yeah, so I'm going to do this over again and just watch it a minute or follow along.
Okay,
So opening parenthesis,
wait,
and
hold on.
the colors will help your eyes not fall off, not accidentally kick the wrong 12. But let's take the AA dorms, that's the O. Let's subtract the E, which is the purple cell referring to the AA dorms expected. Parentheses around that. So now we have O minus E. Let's square that. And then divide by, click back in the cell with the dorm, with the expected AA dorm, the purple right here. And yours will probably be the same cell numbers, so you can check your formula that way since it's hard to see with the colored cells.
Professor, with that equation right there, I don't have to put a dollar sign.
There's nothing that we're stabilizing.
Oh,
You
okay.
see how we're moving referentially through all of these colored cells? And since we're not stabilizing anything, we don't need any dollar signs. Did you get the chi-square, Shandina?
Yeah.
What'd you get? All right, let's see. And that's also what Anitra got. Let's see a couple more answers and make sure that that's right. I haven't calculated it yet. I would like to see a couple more people doing this. All right, we're getting the same answer. All we do is we sum up these cells, these 9 cells. We get the 29.79. So let's go ahead and finish up the problem. Our sample statistic, our chi-square sample equals 21 point, we should get 2 decimal places. It would be 80, I guess. We'd have to round to. And then we make our decision. Our decision, of course, since our sample is much higher than our cutoff point, we're going to reject HO. We didn't write out our statistic, but I did say it'll be something like this. So let's see. So I'm going to copy this and then just sort of tweak it a little bit. So I'm going to write now, turn it into a definitive statement. I'm going to make students, I'm going to put the apostrophe, I'm going to write students' housing preference, and now I'm going to say differ significantly by degree level. And then we can just put our statistic, chi-square And I'm going to show you one more thing at the end of this that real researchers would do for sure. Chi-square, our degree of freedom was 4 equals 21.80. And now before we put our p-value, let's take a look at this chart. If you were a researcher, you'd want to tell, like, not that it's less than 0.05, you'd want to say how significant it was. And in this case, it is even higher than the cutoff point if we were using this extremely rigid level of significance. So I would put p is less than 0.001. That's what I'd do if I was a researcher, because we tested at 0.05, but we actually found that it's not only significant at 0.05, it's significant at 0.001. That's what I would write as a researcher. However, if you write it as 0.05, that's fine, but this would be the better way to write it, 0.001, because that tells our readers how significant this really was. So there we go. That's how we're doing these last statistical test of the semester.
I'm sorry, Professor, can you go right down to the conclusion, please?
There is an interesting thing if you like, if you kind of like to use fancy stuff in Excel, if you grab up a symbol, I'll just show you what it is. I had a little bit of a hard time finding the chi-square, but let's just say we were doing a, we wanted to have mu written in there and we wanted to show up as mu. Let's insert that symbol so we can copy it. And then close this out. Where did it put that right now? Here it is. You can do kind of a cool thing. So I'm copying this mu that I just inserted. I'm going to go down to my options on the file menu, and I'm going to just create a shortcut. I think it's in the proofing menu, and I'm going to just add it to the dictionary. And so I'm going to tell it, I'm hoping I'm doing the right thing here. Let's see here. I shouldn't show this without reviewing the process. Let me just check if I can show you this. If not, autocorrect options. That's where we want to be. Let's go ahead and add that. Let's write something like this. I'm going to put like a funny slash here. I'm going to put this funny backslash in there. You can use whatever you want. You're creating a shortcut. Whenever I type that, I want it to replace with this mu symbol so that I don't have to go into that insert menu all the time. And let's see if that'll work. I'm going to do that now and hit enter. And there it put that mu symbol for me. So if you like cool stuff like that, you can create those shortcuts if you want to use the actual symbols. So now anytime I type this and hit enter, it's going to give me that symbol. Cool, huh? So now I can write, mu. And we could do the same for chi-square. It's kind of messy when you're writing chi-square like CHI. So anyhow, that's all I have for you for today. We're a little early. I can work through anything, other questions that you want to at all. If you
Okay,
have,
your spreadsheets will be saved, right? To where we can access it?
you can't copy and paste all this. No, you have to
Oh,
enter
okay.
your own formulas. But you have the demos. I always have demos of these problems, so you can just follow along with the demo. But no, you wouldn't be learning much if you just copied my formulas. You have to create your own formulas. And by the way, some of you, when you're doing formulas, like, you're typing sum and you're seeing all this come up, like these wizard menus. I mean, I really recommend just knowing how to type the formulas and not using the wizard menus. It'll just help you in general. If you use the wizard menus, it tells you what you need to put in there and all that. But I think it's easier just to know what you're typing. If you use this FX bar, you can look up a formula, round or whatever, and it'll tell you exactly how to do it. And that can be helpful if you don't know. It'll tell you, well, what number is that you want to round? How many digits do you want to round to? I mean, but in general, it's better to just know your formulas. That's why I teach it that way. It's quicker, and then you know what you're doing instead of relying on a black box wizard to tell you. Next week's class, a different class. Barring anything unexpected, I will be sitting here in the classroom and I'll message certain of you that I would like you to come because I want to give you additional help. It's not an insult, it's because I want to make sure you're going to do really well in this class. So I'll message you independently. Otherwise, I won't see you in person again. So those of you who are here, thank you for being here. It means a lot to have students in the classroom. It's like, you know how you have a job and you have a boss who like just always tells you like, you know, is just there and like interacting with you and saying, oh man, you did that. So, you know, like, oh, this is working. Yeah. Doesn't that, it's like nourishment. It's almost like food. And sometimes in students, I have some of you on Zoom, you do really well in providing that nourishment, even though we're remote, but your teachers, your faculty, they need nourishment too. And it's, I often get it, I find it's as much as food for my job, for me wanting to be here and keep doing my job. And so those of you who are really engaging and being here on Zoom and especially in person, I want to thank you. It's meant a lot. And I've enjoyed working with you. It makes it fun for me. So it's been a pleasure. And then all of you should come to the review session. It will be on Zoom only. All right, but we'll do it together. It'll be active. You'll be doing things. You'll be taking little tests. I might put you with a partner to do it, and I might just have you do it individually. And so we'll be working together. Okay. All right. So
Good.
see you either next week or else in 2 weeks. And take good care, everybody, and take care of yourselves as you come up on these exams. Don't let yourselves get overwhelmed. And if you do find it, give yourself 5 deep, slow exhales, calm yourself. In 1 month, this will all be a distant memory. And you know, but I hope some of you like it well enough that you'll take advanced stats sometime, because some of you are really good at this stuff. And advanced stats takes us a lot farther, so you could actually be researchers using quantitative methods. So I hope to see you again down the road. Ajeje, agone.
Pagone, Professoress.
I had a quick question. You said something about the review and people catching up. Is it possible, like, if you didn't get full points for your application, just to redo the questions you got wrong?
Yeah, you can always do that. But when you do it, Chanel, I want you to put in exactly what you changed, what I
Yeah.
should be looking at, because I don't want to like tell me, because I don't want to have to go through and regrade your whole spreadsheet. I just want to look at what your error was and how you corrected it. So highlight it, or better yet, tell me what you did in the little comment box when you submit it. Okay?
Okay.
And yeah,
sounds good.
definitely you can do that.
Awesome. Thank you.
Sure thing.
Take care. Go
You
on it.
Go on day. Yes.
Professor Russ, I had a question.
Okay. I'm not sure who to take first here.
You could
Okay, yes.
you could probably take Alexia first.
Okay, well, she said to go ahead with you, so I can turn the Zoom. Let me stop recording and I'll turn the Zoom off once you're done. Yes, your question.